On what open intervals is this function increasing? What do you think?
Negative 3 to 3.
Negative 3 to 3. Bless you. Absolutely perfect. What does it mean when a function is increasing? It's going up. Negative 3 to 3. On what intervals is it concave down? 0 to 7? 0 to 7, concave down? Would everybody agree with that? With concavity, sometimes you have to approximate. It makes sense. That would be 0 to 7. All right, number 2. On what intervals is this thing decreasing? Now there's going to be a couple of them. We're decreasing from where? Watch it, there's an arrow on that. Negative infinity to negative 3. And then again from 0 to 2. Yeah, you can put a union in between them. Union just means or, and it's those are the two, yeah. On what open intervals is it concave up? Negative infinity to negative 1, that looks good. And then maybe from 1 to infinity? For negative 5 to 7, so just negative 5 to 7, where are we increasing in this picture? This is number 3. What do you think? Where are we increasing?
0 to 2.
Are we increasing from negative infinity to 2?
Negative 5 to negative 5.
Or negative 5, I'm sorry. Negative 5 to 2? Are we increasing anywhere else? 2 to 7. The whole picture is increasing. It's just broken because of the asymptote thrown in there. This is a reciprocal function. Reciprocal functions are increasing functions. They only go up. They only go up, unless you turn them upside down. On what intervals are we concave up? Negative 5 to 2 is concave up. Yep, negative 5 to 2. 4a, on what open intervals is this thing increasing and concave down? So we have to be increasing and concave down. Negative 6 to negative 3. That's the only place that you're increasing and concave down. On what intervals are we decreasing and concave up? Decreasing, concave up. 0 to 3, perfect. Rocking. Number 5. Which statement best describes this graph? Increasing and concave down. I agree with that. What does increasing mean? Going up. And it's definitely concave down. All right, now 6 and 7 are those ones where you have to come up with a picture. So take a second with your friend there, and then I need you to come up and put your pictures on the board. Keeping in mind that our pictures won't necessarily all look the same. picture yet? Did you want to put up here? I found this really cool blue marker, someone can use that. Right? Put it up there. You doing 6 or 7? 6. Definitely, you got 7. Yeah. Anybody got 7? Something for us to start with, anyway? Wow. All right, let's see, let's look at that, if these pictures meet the criteria. So this is number 6, and we're supposed to be increasing from -5 to 1. Yeah. Make that a little bit more defined there. So, yeah, that's going up. Yeah, okay. All right, that part looks good. Increasing from -5 to 1, and decreasing from then on. It's concave up from -5 to -2. That says a little point thing right here. And then concave down, so we can smooth that out a little bit. Okay. On the whole thing? Yeah. Okay. That looks like a point of inflection right there. How does that look to everybody? Is that okay? I think that's okay. You may have it positioned differently, but you have some shape that's similar to that. Okay, this one, I did not, when I was looking at it, I misread it. So we are decreasing basically on the whole thing. And then we're concave up. I'm thinking there's a misprint in there. But let's just go with what we got. It's decreasing on the whole thing, concave up. Concave up from -5 to 0, and then concave down for the rest of the way. So there's your point of inflection. That look okay? Did yours kind of reminds me of a cubing function? Go in the other direction, the cubing function. Yep, we need arrows. Because it goes to the infinities.
What does it mean when some of them are in the brackets and some are
we can, at the actual point, it's really hard to make any conclusion about it ever. So generally speaking, I prefer open intervals. On the AP exam, there is no penalty for having the wrong kind of interval if you're talking about concavity or that kind of thing. For me, it's hard to say that a point is doing anything. A point being concave, up or down, or whatever, that's hard for me to distinguish. So, it doesn't matter. Infinities have to be open, always, but yeah. Here's the way I read it when I first read it. Well, never mind, we're not that. Okay, here we go, worksheet A, the topic 1.2, here we go. Find the average rate of change. Everybody in this room can do this quickly without issue. So let's start in, let's take a minute, do these 4 average rates of change, 1, 2, 3, 4, and we'll compare answers.
Square root, you want us to put plus or minus?
Oh, no. So we only put plus or minus if we are putting the square root in. So, like if you were solving x squared equals 9, you would put the square root in, then you do plus or minus. But if it's already there, it's whatever it is. Rates of change are supposed to have units, but in a problem like this, we don't know what units, so we'll just leave it be. With the complex fraction here, somehow simplify that. We should get the same answer, even though you might do it differently than I did. I like to multiply by 7, get rid of all my fractions. You might do it differently. How do those look? Do I make any careless arithmetic mistakes? Do we match? Anyone have a question about that? You know what to do? Yeah, cool.
On number 3 with the square roots, like, why would we not do plus or minus?
Okay, so first of all, we don't change our problem. Our problem says h of x is this. So that's what it is, okay? There's no plus or minus in there. The rule is, as I told him, if you put the square root into the problem, if it's not there, but you put it in, then you have to consider plus or minus. So if I had to solve this equation, I would take the square root of those sides.
So that would be plus or minus
That
3?
would have to be plus or minus.
Okay.
Because if you put the radical in, it's plus or minus.
But if they already had the radical there, it would
It's
just
whatever sign it has. And this is a positive one. But we could have a function that looked like this, right?
yeah.
That could be a function. Then I would use the negative one because that's what's in the problem.
All right. Thank you.
All right, so one last check. These okay? All right, let's move on to the pictures. Now, I want to make sure, I kind of assumed that we all knew how to interpret the graph. I want to make sure that's true. So we need P of 6 minus P of 1 over 6 minus 1, okay? P of 6 is a y value. Remember, y is the same as f of x, right? So this is a y value. It is the y value where x is 6. So the y value where x is 6 happens to be 1. So that's a 1. Now, what is the y value when x is 1? -2. So that one is 3/5. All right, do the second one, do number 6. Same thing. You need to find the y values at the given x values. What's m of 9? -3. And m of -2 is 3. Did you get -6/11?
Yes.
Remember, it's a subtraction. It's a subtraction.
Are you allowed to just count like lines over on the graph?
Yeah. Now, you can do that, but not if this is an exam question. This has to be shown if it's an exam question. They're not going to grade that without this, so you need to have that formula. But yes, that's what it amounts to, with the point to point. All right. Now do the same thing with the table. Find the average rate of change from 1 to 8. Those are table values. So your x is 1, your y is -2. So when you do f of 8 minus f of 1 over 8 minus 1, f of 8 is 3, f of 1 is -2, I got 5/7. What's your thought about number 8? What's your rate of change formula look like? This is going to be what? N of 5 minus n of c over 5 minus C? What's n of 5? 21. What's n of C? C squared minus 4 over 5 minus C. And we know that that has to equal what? The rate of change is equal to 3. So we have an equation now that looks like this. So 15 minus 3C, I'm going to bring this over here. 15 minus 3C equals 25 minus C squared. Oh shoot. I could have done something different, but oh well, this is fine. This is fine. Minus C squared plus 4, everybody okay with that? What kind of an equation is that? Quadratic. Let's get it set equal to 0 and see if we can figure out how to solve it. So C squared minus 3C minus 10. Did I do that right? I moved everything over here. Is that factor? Yeah. And you can always use the quadratic formula. This one happens to factor. So it looks like C is 5 or negative 2. Wait a second. Can C be 5? No, that's extraneous. Look what would happen in my formula if C were 5. What would happen? I get a little 0 at 5. That's not good. That's extraneous. So the answer is negative 2. Now, I didn't pay close enough attention. Back here at this point right here, I just jumped in and said, okay, I'm going to solve this, get a set equal to 0. But if I would have cleaned up that numerator first and gotten 25 minus C squared, what do you notice about 25 minus C squared? It factors into the difference of squares, and so I'll have 5 minus C, 5 plus C, over 5 minus C. I can cancel that and just solve the equation 5 plus C equals 3, which is going to give me negative 2 without the extraneous part. Doesn't matter. As long as you remember to take this one out, it doesn't matter. Perfect. All right, now, you're going to need a calculator for this one. These numbers are horrible. But this is a multiple choice question. Which of the following approximates the average rate of change from 2008 to 2010? Go ahead with your calculator, figure that out. The average rate of change from 2000 in Kansas, this is from Kansas, for agriculture, natural resources. So that would be the first row from 2008 to 2010. Use a calculator or do it in your head if you want. Whatever works. Yep. Yeah, go ahead and grab your stuff. The period's almost over anyway.
Wait, grab my.
You have to take your stuff with you. When you get there, ask her to email me and let me know you got there, okay?
Alright.
Okay, did you figure it out yet? I read the problem. So which one? Remember, these numbers are in thousands. In the table, they're already in thousands. So put 3 zeros on whatever answer you got. And which one is it closest to? 65 million? Everybody get that? All right, we're gonna do a couple more and then we're out of time. Worksheet 1.3, here we go. Determine if the function could be linear, quadratic, or neither. The first thing your beady little eyes need to pay attention to is those input intervals. We're going from 1 to 3 to 5 to 7 to 9. Are we going to be able to draw conclusions from this? Yes, because those are all equal length input intervals. Remember, if these aren't equal length, the only kind of function you can determine is linear, because it doesn't make any difference in linears because it's the same. All right, so let's see what we've got here. All right, so these differences, let's see, I'm going down by 3, down by 1. Up by 1, thank you, up by 1, and then up by 5, and then up by 9. Let's look at the second, this is the first differences. Let's look at the second differences. This one's going up by 4, this one's going up by 4, and this one's going up by 4. What kind of a function has constant second differences? Quadratic. That is 100% quadratic function, because its second differences are constant. All right, I'm going to stop there. We'll finish this tomorrow,
We don't have class.
Friday, and then count on a quiz on Monday. Okay? 1, 1 to 1, 3. Huh? We have 1, 1, 1, 2, 1, 3.
Oh,
That's it.
One for the do that, right?
yes. Then you.